I have page 365. Okay, so we have a large ice cube. So here's the ice cube. Okay. It's melting. Each side is shrinking by 2 inches per minute. 2 inches per minute. I have to figure out what this is, because if I don't know what that is, I don't know what to do next. So what is this? 2 inches per minute.
dx over dt.
Thank you very much. Excellent. Find the rate at which the volume is changing. Okay. When, remember, whatever follows after when, or at the instant, at the moment, has to be the last thing to think about. When the length of an edge is 15 inches. Assume that the cube maintains its shape. So what am I asked to determine?
Isn't it dv over dt?
Absolutely. Thank you so much. That's all I needed to hear. Good. Excellent. So then we start where? So after we have a picture, we understand what was given. We understand what is the problem is asking us to do. We understand that whatever follows after when has to be forgotten. Has to be completely forgotten till the last step of the problem. Where is my starting point then? What do I do first? What do I have to write first?
The equation.
Okay, ready?
So I guess v equals x cubed.
Excellent. And then I have to differentiate both sides. Remember that this is a function of time and this is a function of time. So this will be dv over dt, oops, over dt, and this is 3x squared dx over dt. So that's what I'm asked to find when x equals 15. And dx over dt is given to us as 2. So then I have 3 times 15 squared times 2. So this is 3 times 2, 25 times 2, or 6 times 2, 25. So what do I get? 0 and 3, 12, 5 and 1, and I think 14. 13. 1350. Measurement unit.
Inches per minute.
Oh.
Say it again.
Inches per minute.
Inches cubed.
Inches cubed per minute. Excellent. Good. Is this good enough? Is this okay? Is it clear now? Anyone? Second question? Next question?
Professor, I made a mistake on that one because I've read the problem wrong. And one of the measurement units, I had one as inches and the other one as centimeters. So I
That's
mixed
okay.
up the problem with that. So
Just remember, before you write the measurement unit, we always think of, okay, what am I determining, right?
I also had one thing on that question.
Yes, Brandon, can you repeat your question? I'm sorry.
For mine, I looked at the question, it was asking the rate, so I put negative, so minus 1350 cubic inches per minute.
Because this is decreasing. That's why.
I put negative. So
yes, because this is negative 2. Correct. Thank you so much. Thank you.
My bad. I thought I got it wrong.
No, I did. Of course, the volume is melting, right? So it clearly states it's decreasing. Let me read the problem one more time. It should be in there, and I just, each side is shrinking. Absolutely. Because it's shrinking, this is negative. Because this is negative, this will automatically be negative. Thank you. My apologies. The word shrinking got me this time, right? I should have put the minus because shrinking is very clear. It's melting. Thank you. Thank you, thank you, thank you. Keep me on the right track. Good. Next question. Anything else you need help with? My lab math? Everything has to be done tonight, right? Please. I haven't checked. Our test is on Wednesday. From 2.1 through 2.3 and 3.1 through 3.9. Of course, not 3.7. We haven't talked about 3.7. Okay, next question. Anything you'd like to work on? If you don't have anything, then I will choose. Anyone? Is all homework done? No one needs any help with my lab math? Nothing?
Yes? Can we do
yes?
number 14?
Yes?
For 3.9 exercise set?
Yes. So you said 14 in 3.9. From where? From my lab math? From...
no, the actual chapter.
Okay.
Book.
Very good. 14. Let's take a look at 14. Got it. So they're giving us that y equals 1 over x squared. This is what I see, 1 over x squared. Find the x over dt when y equals 16 and dy over dt equals negative 0.8. Is this the problem? Am I copying the correct one?
Yes.
Okay, perfect. So remember, this is gibberish. These follow after the word when. If they follow after the word when, they have to wait till I'm ready. Okay, so one option here is to cross multiply. This is a proportion. Now, dx over dt tells me that x is a function of time, and dy over dt really means that y is also a function of time. So because it's a proportion, I'll cross multiply, and I get 1 equals x squared y. Now I will differentiate implicitly, keeping in mind that this is a product, and furthermore, these are functions of time. Good. So the left-hand side prime is 0. The right-hand side, I have to differentiate x squared, 2x times the inner function prime times the second function, then plus the first function times the second function prime, but it's a function of time, and it's dy over dt. Now I see they want us to find dx over dt, so I'm going to solve this equation for dx over dt. This is my variable. So this will go to this side, or this will go, it doesn't matter. One, I have to separate them, and then divide by 2xy. So then negative x squared dy over dt equals 2x y dx over dt. So finally I'm solving for dx over dt, which is this whole thing is at the top, exactly how I see it. and divided by 2xy. Now I'm ready for this. When y is 16, and then dy over dt equals negative 0.8. They're not giving us x. Well, I can also simplify by one of them and get negative x over 2y times dy over dt. They're not giving us x, but I have this as being negative 0.8, and I have y as being 16, and I have the equation y equals 1 over x squared. So if y is 16, I cross multiply, right? I already have that. So I have 1 equals x squared times 16. Or x squared equals 1 over 16. Or x is the square root of 1 over 16. Are they telling us what happens to, they're not telling us, but y is positive. So they're not telling us we're going to get two different x values. So let's continue. So we have that x squared equals 1 over 16, and now I take the square root, as we know, equals plus or minus 1/4. Okay. So I don't know what they want. They want us positive, it doesn't say. They want positive 1/4, they want negative 1/4. No clue. So dx over dt, when y equals 16, x is plus or minus 1/4, and dy equals over dt equals negative 0.8, then this whole thing would be negative plus or minus 1/4 over 2 times y, which is 16, times negative 0.8. So this will make positive, the negative with a negative. So then from here I have plus or minus 1 over 8 times 16, and the top is 0.8. There is no indication. So they're giving us y, but they're not giving us x. So from here, from y, I have to find x, because otherwise I cannot determine this. I have to find x because I have just y and dy over dt. Good. That's my page 2. So whatever I get here, 0.8, 0.8 divided by, in parentheses, 8 times 16. So I get approximately 0.00, oh, it's just exact actually, 0.00625, but it's positive or negative. Because they're not telling us which one they want. It says given, find, doesn't say. Find dx over dt when y equals 16, and dy over dt is negative 0.8, but they're not telling us which one to use. Good question. It was very good. What else you would like to work on? Do I get to choose now, or do you still have anything for me? Or I will choose. Anyone? Okay, I guess you're going to tell me if you need anything else. In the meantime, I will choose. I'm going backwards now to 3.8. So we looked at a couple of examples on 3.9. I'm walking my way backwards. So here's an example. What if I'm asked 2x cubed y cubed equals negative 18 and negative 1 comma 3. And the question is problem 21 on page 359. They're asking us find dy over dx. That's the first question. And question number 2, evaluate it. Evaluate it at negative 1 comma 3. Okay. So in order to find dy over dx, this is clearly specifying or telling us that y is a function of x. So in order to do that, I have to differentiate both sides implicitly. And remember that this is a function, this is a product, and only this is a function of x. But it's a product of two functions, function 1 and function 2. So let's find the product, differentiate the product. Okay, so this is my page 4. So 6x squared times y squared plus 2x cubed times 2y dy over dx equals 0. Is this okay so far? Do we have any questions on this step?
No.
Good. So then we move on. My variable is this. So what I have to do is move this to the other side and divide by 4x cubed y. So 4x cubed y dy over dx equals negative 6x squared y squared. So finally dy over dx equals this over this with minus in front. 6x squared y squared over 4x cubed y. Simplify as much as possible. I remove 2 x's from here with 2 from here. I remove 1 y from here with 1 y from here. And a 2 from here with a 2 from here. So then I get negative 3 halves, a y at the top, and an x in the denominator. Everything else is gone. So now they're giving us the x and the y they want us to evaluate and find the slope of the tangent line. X is negative 1 and y is 3. So this is negative 1 and this is 3. So 3 times 3 will be 9 and 2 times negative 1 will be negative 2. Final answer, 9 halves. If I'm asked to find the equation of the tangent line, no problem. I will have y minus y1, y minus 3 equals the slope, and then x minus negative 1. So that will be x plus 1. Can I find the equation of the line? Yes. I will distribute 9 halves x plus 9 halves and plus 3. The least common denominator, I multiply this by 2. So y equals 9 halves x. 2 times 3 is 6. 6 plus 9, 15. The problem is not asking us to determine this, but I just wanted to refresh your memory on how to do it.
I only had one question, and
Yes?
it's not fully related to the problem, but like on the test or something, when do we know when we should use dx over dy? I mean dy over dx, and when should we use like dx over dt and dy over dt?
Okay. So remember when we had the y over dt and the x over dt is when the rates are related and when the time is involved. X and y functions of time? It's a very good question. Y function of x. Excellent question, actually. Thank you. Who was that?
Brandon.
Brendan, thank you. So here, it's basically under related rates, in which x and y are both functions of time. So what we had before, at the beginning of the class, see, this is the y, and this is the x. Both of them are functions of time. So this is the function. In this case, it was v, but it could have been y, dy over dt and dx over dt, and they are involved in an equation. And this is the equation they are connected by. And they are both functions of time. Now,
Alright, so just whenever they're both functions of time.
Yes.
On a per minute.
Then we do have dx over dt, and we have dy over dt. We can have dv over dt, and so on and so forth. Now here, we're normally given an equation, and we are not told that y is a function of time. We are told find dy over dx, which specifies that the equation contains one function and one independent variable. Here, the equation will involve at least two functions of time of the same independent variable. But see, x and y here are functions, and they do depend on the same independent variable. But here, it says find dy over dx, which means y is a function of x. And x, in this situation, unless otherwise specified, x is not a function. So in this case, x is the independent variable.